I will talk about the potential of past and often forgotten knowledge and technologies when it comes to designing a future sustainable society. Now, often when obsolete technologies are brought to our attention, it is with the intention to make fun of them. The acoustic mirror, what you see here, is but one of many examples. But our tendency to look down on the technology of our ancestors, an attitude that is called temporocentrism, is rather misplaced because we do not have the monopoly to innovative solutions. Take the optical telegraph, for instance, which can be considered the email of the 18th century. And more than 200 years ago, it was already possible to send text messages throughout Europe and parts of America at a speed of 1,200 kilometers an hour, and this wireless and without the use of electricity. And all you needed basically was a chain of towers, wooden semaphores, and lots of guys on towers looking through telescopes. Now, it is not my intention to replace the internet by the optical telegraph, but the history of technology hides lots of innovative solutions that can be interesting for the future. And some of them can be copied without any changes. One example is the Timbrel Vault, which is a technology that dates back more than 700 years ago, and which is actually a building technique that uses very small amounts of building materials and thus saves lots of energy. And it was rediscovered recently, for instance, in a museum in South Africa built by Peter Rich. This is what you see here, and this is from the outside. So a Timbrel Vault is just several layers of overlapping tiles that are woven together with a fast-setting mortar. And it's a very thin structure, but it is as strong as steel. So you could save lots of energy building houses in that way. Even more often, interesting possibility arise when you combine old technology with new knowledge or new materials, or when you apply old concepts or traditional knowledge to modern technology. Now I will give several examples of this, but first I have to explain why the present day approach to sustainability is wrong and doomed to fail, actually. There are, our modern industrial society is heavily dependent upon continuous supply of fossil fuels, gas, oil, nuclear. And I think that by now most people agree that we have to do something to address problems like environmental degradation, peak oil, and global warming. And out of this concern has come a kind of consensus that we can engineer our way out of it by using more sophisticated technology. There is a debate over whether we should produce electricity using renewables or using nuclear, but basically almost nobody questions the fate in what is generally called green tech, clean tech, or ecotech. Here you have some common examples. There are many problems with this approach. I cannot talk about them all, but I will focus on two quite fundamental problems. The first is that all this ecotech is dependent on a continuous supply of fossil fuels. For instance, solar panels and wind turbines, they don't need energy, they don't need fossil fuels to operate, but you need lots of fossil fuels to produce them. You will not find any factory manufacturing PV solar panels or wind turbines using energy from their own solar panels or wind turbines, because it is very inefficient and thus very expensive to convert electricity into heat. And heat actually is what you need most to build things like solar panels and windmills, for instance, to make steel, to make silicon, which is the basic material for solar panels and microchips, by the way. So this is a bit problematic, especially because you have to produce these technologies not once, but every 20 to 30 years. We have to design new wind turbines, we have to make new solar panels, we also have to make, every 5 to 10 years, we have to make new batteries. Batteries are a fundamental element of electric cars, of renewable energy storage. So you need a huge input of fossil fuels to keep running a society that is based on renewables. This also means that you often hear people say, like, fossil fuel prices have to go up in order to make Ecotech more cost competitive. That's not really true, because the production of these technologies are dependent on fossil fuels. So whenever the fossil fuel prices will rise, production costs of Ecotech will rise also. Now that's the first problem. The second problem is that energy efficient technology does not save energy. And worse even, more often it leads to more energy consumption and not less energy consumption. This maybe sounds a bit weird, but it's quite easy to explain. For instance, if you look at the history of cars, you all know this one probably. You would think that by now we would have managed to build cars that are more efficient than this one, which came on the market more than 60 years ago. But in fact, it is not true. The 2 chevaux consumes as much energy, as much fuel as the smallest car of the same manufacturer today. So what happened? There was definitely progress in more efficient engines. We made engines that were much more energy efficient. But the problem is that this progress was not converted into energy savings. It was converted into extra comfort, more electronics, higher speeds, and more weight, especially. So the smallest Citroën today is like twice as fast, twice as heavy as the 2 chevaux, and it has an engine output that is 8 times higher. So that's where all the progress in energy efficiency has gone. The result is not just the status quo. It's much worse than that, actually, because this is also a product of energy efficient engines. These cars would be too expensive to drive if we would not have the progress in energy efficient engines. So here you have an example of energy efficient technology that eventually leads to more energy consumption and not less energy consumption. There are no savings here. It is important to note that energy efficiency brings us many advantages, and that's why we all love it, while nobody is against it, actually. Energy efficiency brings us faster cars, bigger cars. It brings us larger screens, larger televisions. It brings us more computers. It brings us more powerful computers. But it does not make us any less dependent on fossil fuels, which is, as you will remember, the whole purpose of Ecotech is to make us independent of these things. Underlying this common view of high-tech, sustainable society is the belief that we do not have to change our lifestyles, our luxurious lifestyles. Now, this is not a realistic view, but it sells, of course. It's what we want to hear. However, my message is that changing our lifestyle does not mean that we have to go back to the Middle Ages and give up all modern comforts. A downsized, sustainable industrial civilization is very well possible, and Ecotech can be part of the solution. For instance, if we would put an energy-efficient combustion engine of today in a car that is as low-tech and slow as the Deux Chevaux, the result would be a car that is the most economical automobile in the world. It would even be better than the electric cars that are sold today. Now, driving a car at 60 kilometers an hour is a change in lifestyle. It's slower, but it is still 10 times faster than the travel speed in pre-industrial times, when most people had no other choice than to walk. So it's somewhere in between we could end and make all this energy-efficient technology really work and bring results. Of course, the same strategy can be applied to many other technologies, not just cars. But what I want to focus in the rest of this talk is not consumption, but energy production and storage. We can learn a lot from the way that energy was produced before the Industrial Revolution. Renewable energy has been tried before and to great success. From the 1100s onwards, Europe became the first civilization which made use of windmills and water mills on a very large scale. At the peak of their popularity, which was right before the Industrial Revolution, there were an estimated amount of 200,000 wind-powered mills and 500,000 water-powered mills in Europe. Initially, they were only used for grinding grain and pumping water, but from 1600 onwards, lots of new applications appeared. From then on, water and wind-powered mills were used to saw wood, for instance, to polish glass, to make paper, to drill pipes. And I could go on with these images for 20 minutes, because in total more than 100 industrial processes were powered by water or wind. Now, it is said that one of the most fundamental problems of renewable energy today is storage. The wind, there's not always wind, there's not always sun, so with solar panels and windmills and wind turbines, you cannot always generate energy. So how did the medieval people, pre-industrial people, solve the storage problem? They had no batteries, obviously, so they had to find something else. One solution was to use a backup of animal power, mostly horses working capstans. But this was not a very efficient solution, because to use horses need food, and to grow food, you need valuable agricultural land that has to be worked by people and more horses. So this backup solution was only used for critical processes, critical industrial processes like food production and especially grain milling. For all other industrial processes, our ancestors used another storage strategy. That is, they were not storing energy, but they were storing work. So what they did is they let go of the need to produce a maximum output of energy 24 hours per day and 365 days per year. For instance, in windmills, this meant that the miller was working whenever the wind blows, whether it was day or night, or even on Sundays. In the Middle Ages, the only people who were allowed to work on Sundays were millers. On the other hand, when there was no wind, the miller took a day off, or he did other work, like maintaining his windmill. The same strategy was actually applied to sailing boats, to transportation. They became the most important means of transportation from the end of the Middle Ages. And well, when there was no wind, the sailors just stayed ashore. And when there was wind, they were gone. We could apply that same storage solution to our modern technology. We could produce things, we could make things whenever the wind blows or whenever the sun shines. And storing work instead of energy could be a huge advantage because it eliminates the need, or at least drastically reduces the need for a backup infrastructure, like, for instance, batteries or a super grid that spans the whole world to send energy, or a backup solution of fossil fuel powered plants. So you save a huge amount of energy, of money, and materials. I know of only one example of a present-day renewable energy plant, a windmill actually, that works this way. And that's the wind-powered knitting machine by Dutch product designer Merel Karhoff. It knits scarves when the wind blows. And only when the wind blows, so it doesn't work when there's no wind. You could apply the same system to much larger factories, to the whole industrial production actually. But of course there is a price to pay here. If you could only produce scarves or other goods when there was wind or when there was sun, then production would be lower. But we should remember that overproduction and overconsumption of goods, of products, is one of the main reasons why we are in an environmental and energy crisis. So they should be solved anyway, and this could be one way to do it. There is more to learn from this wind-powered knitting machine and from the use of renewable energy in pre-industrial times. Windmills and water mills generated mechanical energy that was transferred directly to machinery. Here you see the interior of a sawmill. What our wind turbines do it very differently. They generate mechanical energy to produce electrical energy, which is then back converted to mechanical energy. This is, of course, a very inefficient process where lots of energy gets lost. So we could do the same. We could do things without the intermediate step of generating electricity, which sounds very old-fashioned, but which is actually much more efficient. Now, there are, of course, some modern devices that cannot be powered directly by mechanical energy, like computers, like flat-screen TVs, like light bulbs. But all industrial processes that were powered mechanically in the Middle Ages could still be powered mechanically today. And this is especially interesting when we start talking about solar energy, which we think of as another way to generate electricity, but which can also be used in a direct way. And this is very important because it gives us a renewable, an inexhaustible renewable source of heat energy, which is what we need to build wind turbines, to build solar panels, or to build more, basically everything. So 70% of energy use in industry is heat energy in Europe, which wind turbines and solar panels can only deliver very efficiently. And still, this is the only thing we are talking about, wind turbines and solar panels. So we have now concentrated solar power, an invention from the end of the 19th century. And it is already used to produce electricity in deserts, but it is only cost-effective in deserts because it is transferred to electricity. If you use it directly, like in this machine, it's a French machine designed in 2010, it's an open source machine. you can actually make this technology cost-effective even in less sunny regions, because you win actually 2/3 of energy that doesn't get lost in the conversion to electricity. And this machine is very important because just like a medieval windmill or watermill, it can be used to build itself. So you can use this solar energy to build another solar machine, because it can reach temperatures to 700 degrees, recycle aluminium, and thus make the material for its reflectors. So you have a technology that can be used to produce more renewable technologies, which our wind turbines and solar panels cannot do. Thank you.
Thank you so much for helping us think outside of our electronic boxes. I have one or two questions for you. If you could, just because we need to switch from one computer to another. The first question that came out of Twitter, I guess, or Evenium, is that this seems to be okay for very small communities. Oh, have a mic. What would be the realistic drivers for billions of people?
Well, I think it would work on every scale, because I know where the question comes from, because we have the impression that these things are less efficient, while actually they are more efficient. So when you use direct mechanical energy, for instance, you need to build much less energy production plants. So there is basically not one reason that this could not be applied on a very large scale, on a worldwide scale, in a modern industrial society.
And the second question was, how can we teach low-tech design, for example, in design schools? And what comes after that is that because most of them have courses driven by improvements in technology.
Yeah, well, I think we need a lot of improvement. For instance, the solar energy you saw in the end, it's still a technology that's very much in its infancy. So it has to be improved a lot. There is a lot of work to be done to improve these things. And it's just in another way, it's kind of how are we going to design industrial processes so that they can run on an intermittent source of energy. So to make sure that, for instance, when the sun disappears behind the cloud, that the process doesn't stop. That kind of things. There is lots of we need lots of innovation to make these things work on a large scale.
Part of the answer is we need to teach that in design and engineering school.
Yeah, yeah.
Thank you very much, Kris.
You're welcome.